Okay, so how about we change the rectangles for bouncing balls instead? Let's go ahead and change everything right after the let location. We'll leave that. And right where we're creating this box, let's go ahead and delete that. And we'll put in this code here to create a ball instead. There are two new things here. First, we're using the circle of radius initializer for the SK physics body to add circular physics to this ball. That's because using rectangles would look strange. Second, we're giving the ball's physics body a restitution or bounciness level of 0.4, and those values range from 0 to 1. Something to note, the physics body of a node is optional because it might not exist. We know it exists because we just created it, so you're always going to see this force unwrapping with the exclamation mark after physics body. So now if we go ahead and run the game, we're going to see a bunch of bouncing balls that we can create. And they go ahead and they bounce and fall just like the squares did. They're not very bouncy, but that's okay. You can play with this number right here, 0.4. If you want to make it even more bouncy, say 0.9. And this goes ahead and gives it a lot more bounce to them. And it's a realistic bounce in terms of how it's hitting the other object in terms of its angle. Now, how about we add something for the balls to bounce off of? In the content folder, I provided you with a picture called bouncer.png. So we're going to place that in the game now. And just before the end of the did move to view method, let's add some code. There's a new data type in there called CG_point, but like CG_size, it's very simple. It just holds the X and Y coordinates. Remember, SpriteKit's positions start from the center of nodes, so X of 512 and Y of 0 means centered horizontally on the bottom edge of the scene. Also new is the dynamic property of a physics body. When this is set to true, the object will be moved by the physics simulator based on gravity and collisions. When it's false, as we're setting it, the object will still collide with other things, but it won't ever be moved as a result. So using this node, the bouncer node will be placed on the screen and the balls can collide with it, but it won't move. So if we go ahead and try it. So there's our bouncer node, and our balls will go ahead and bounce right off it. And as you can see, this doesn't move because we set the dynamic property to false. So adding a bouncer took 5 lines of code, but our game needs more than one bouncer. In fact, I want to put 5 of them evenly distributed across the bottom of the screen. Now, you could just copy and paste that code 5 times and then change the positions, but hopefully you realize there's a better way, and that's creating a method that does all the work for us, and then calling that method each time we want to create a bouncer. And the method code is nearly identical to this code that we just wrote that created the bouncer here. So let's make the method and we'll place that code inside of it. So I'll go ahead and I'll take all this bouncer code. We'll cut this right out and we'll put it right in our function. And instead of setting the position to this hard-coded number here, let's set it to our position parameter. Okay, with this in place, we just need to call the function whenever we want to create a bouncer. So let's go to did move to view, and we'll create it in here at different locations. Now I'll go ahead and copy this call, and I'll just paste it in 5 times. And we'll give it some different numbers. So now if we go ahead and run it, we'll have 5 bouncers evenly spaced along the bottom of the screen here. And we can go ahead and create some balls and they'll drop off the bouncers. In a nice way. And we'll probably want to change this number down again. Let's put it back to 0.4, which will be better for this game.